Good evening, children. In the last class, we have studied the first chemical properties of metals and non-metals, that is reaction with oxygen. So we have seen that if the metal will react with oxygen, so what kind of a product we used to get? Like that, if like non-metals will react, then what we used to get? Like that, this all we have seen. So we have seen that if metals will react with oxygen from where? It is coming from air. So they used to form metal oxides. So these metal oxides are basic in nature. So we have seen even a few activities to prove that. Like that, if it comes to the non-metals, so non-metals, they will react with oxygen and they will form uh, non-metal oxides, that is called as acidic oxides. So we have seen the exemption cases between the term also. So non-metals, they will form, it's like acidic oxides. Understanding means metals in bases and non-metals in acids. So if we'll take base, so magnesium hydroxide. Understanding name of the metal which is present here is magnesium. So like that, if we'll take sulfur, suppose non-metal, so sulfurous acid, we have seen that reaction also. Sulfur is the non-metal. Like that, if we'll take calcium hydroxide, calcium is the metal. Like that, if we'll take sulfuric acid, so sulfur is the non-metal. So like this, metals is present in bases and non-metals is present in acids. So now here, you please note that most of the non-metals will form acidic oxides. I'm saying you not all the thing, most of the thing. So most of the non-metals, understanding, form acidic oxides, acidic oxides, understanding. But here there are some exceptions are there. Few non-metals, understanding, few non-metals will form not only the acidic oxides, they will form neutral oxides, means neither basic or neither acidic or nor basic. So they will form neutral oxides also. So this is only few. So for example, if we'll take hydrogen, so hydrogen is a what? Hydrogen is a non-metal. Understand? So if we'll take hydrogen, which is a non-metal, will form neutral oxide called as, if it will react with oxygen, it will form neutral oxide called as water. So we know that water is a commonly known as water. H2O is commonly known as water, which is a neutral substance. Understanding? So like this, a few non-metals will form neutral oxides also, but basically most of the non-metals will form acidic oxide. So this is about reaction with oxygen. So now if it comes to the next second reaction, that is reaction with water. So if the metals will react with water, what is the products we used to get? Means the chemical reaction. Like that, non-metals will react with water. So what is going to happen? So like this, we are going to study now. So now if it comes to the reaction with water, so when first let me comes to first Roman number 1, that is when metals. So metals. So if we take the metals, when the metals react with water, then metal hydroxide and hydrogen gas are formed. You remember. So if metal will react with water, metal plus water, if the reaction will goes, then we used to get metal hydroxide. We will study the examples also. We used to get metal hydroxide, and also understanding, we used to get hydrogen. Understanding? So this is the a common equation when the metal is reacting with the water. Understanding? So here the vigorous of reaction of a metal with water depends on its chemical reactivity. Understanding? So it means the intensity of the reaction, how much fast and how much heat energy will release, either it is explosive reaction and all, depend upon the reactivity. Understanding? Means a few metals will react fast and few metals will react slowly, and few metals will produce a lot of heat energy and all, like explosion. Understanding? So some metals react vigorously even with the cold water, and some metals react with only hot water, and some metals react with steam. Steam means when the water is in vapor state. So whereas some metals do not react with the steam. Understanding? Suppose if we'll take for example, understand, see that these all are the forms of water, but if depend upon the reactivity nature of the metal, it will react. A few metals, even we no need to heat the water, just for the cold water itself they will react. Suppose if we'll take for example sodium. So sodium is a very reactive metal. Sodium symbol is what? Na. Understand? You remember it has taken from the Latin word. Understand? So if we take the sodium metal, so sodium is a very reactive metal, therefore sodium metal react very violently. Understanding? Even with the cold water itself, reaction will take place. Like that, if we'll take magnesium, So magnesium Mg. So magnesium is comparatively, understanding, less reactive to the metal. So it is slowly react with, it is very fastly, and it is slow reaction with cold water. Cold water. Understanding, but it reacts very rapidly with hot water. Remember, hot water. Understanding. So when it reacts rapidly only with hot boiling water, or else if you take instead of steam also, it will react very rapidly, but cold water very slow reaction. Understanding. So the metals like zinc and iron, if you take zinc, Zn is the zinc, and iron is Fe. It is Latin words. Understanding, ferrous. So if you take iron and zinc, they are very less reactive with understand. They will react with, which react slowly even with the steam also. Even with the steam also, they will react very slowly. Not cold water very slowly, hot water also slowly, and even with the steam also, they will react very slowly. So like that, if you take metals like copper and silver, so copper symbol is Cu and silver symbol is Ag. Understanding? So if you take, if you want, you can write just copper and silver. So if you take copper and silver, understanding, and if you take gold also, so these are very less reactive metals, and they are always like they are very unreactive, you can write. These three are unreactive, they won't react. So they are unreactive, and they do not react with water or even with the steam. So the reaction of sodium metal with water we will see first now. So because it is even cold water, it can react very rapidly and vigorously. So if it comes to the cold, first one, that is sodium metal. So if you take the sodium metal, so sodium metal will react with cold water itself. So means if you take the water, this is called as symbolic equation, word equation we used to call. So it will form, what we used to get? We used to get hydroxide first, metal hydroxide. So here metal is sodium. So we used to get sodium hydroxide. I will write the chemical formula also. If you are interested, you can learn. So sodium hydroxide plus, it is along with that we used to get hydrogen gas. Now I will write the symbols. So sodium symbol is Na, understanding, plus water we used to represent with H2O. So we used to get sodium hydroxide, the symbol is NaOH. You remember, small a and capital O and H. Understanding? So NaOH, which is a base. Understanding? So you remember, so base contains, understanding, metal. So sodium is the metal here. Plus hydrogen gas. Hydrogen element will represent with the H, but hydrogen gas will represent with the H2. Why it is, we will study in higher classes. You no need to worry. Understanding? So here, the gas liberated when sodium metal react with water is what? That is hydrogen. So any kind of metal will react with water, so they will release hydrogen gas. Understanding? So are you able to understanding or not? So here the sodium is a very reactive metal. Even it will react with even moisture also. So that is why oxygen and other gases present in air. Understanding? Because here this is a very powerful metal, very dangerous metal. If you will expose to even atmosphere, it will start reacting with the moisture which is present in atmosphere and oxygen and other gases present in air. So if the sodium metal is kept exposed to air, then it will react with various components of air and will get spoiled. Understanding? So that is why always we will store this sodium metal. Understanding? To prevent its reaction with the moisture and other gases of air, sodium metal is always stored under corrosion. Understanding? So inside the corrosion only we wish to store. So with the corrosion, it is no reaction. Understanding? So inside the corrosion we have to store. So metal is also very, understand this like that like this sodium. If you take the potassium, so potassium also a very reactive metal, like almost like sodium and potassium, they are equal reactivity in nature. So potassium metal is also stored under corrosion. So always you have to remember here one bit. Potassium and sodium, they will store in corrosion, not in water, because they will react very dangerously with the water, very fastly, rapidly with the water, and they will causes for the explosion. That is the reason. Understand? So like that, if it comes to the non-metals, so this is about metals. You can learn this one example is enough. Understand? So if you want second example also, I will write potassium. So potassium symbol is K. So K will react with water. Then we used to get potassium hydroxide, KOH, plus we used to get hydrogen. Understanding? Hydrogen gas. This is second reaction. So if you want, you can learn. Understanding? Potassium symbol is K. Okay. So this is about metals reacting with water. So now if it comes to the non-metals, so non-metals, how this reaction will take place, we'll see now. So metals got, now second one is what? Non-metals. So if we'll take non-metals, understanding? So if we'll take sulfur, let me take first reaction. So if we'll take the non-metals plus water, and if you try to observe is there any kind of product is coming or not, so you can observe that no reaction will take place. So R into N I will write, this is a shortcut for reaction. Shortcut I will write, in future I will write like this only, shortcut for reaction. So you have to remember. So here from this I can say that if any kind of non-metal will react with water, so no reaction will take place. Understand? So that is the nature of non-metal. So if we'll take suppose sulfur, so sulfur symbol is what? If you want, you can write. So if we'll take the sulfur, so sulfur plus water, if we'll take water, then no reaction will take place. Understanding? So sulfur does not react with water. So in fact, some of the reactive non-metals are kept under water to protect them from the action of air. Understanding? So some non-metals, they will react very fastly with the air. If they will expose to atmosphere, they will react with air, means air contains different kind of gases. So that is why we will, like that non-metals will keep under water to protect from air. For example, if we take phosphorus. So phosphorus if we'll take, so phosphorus symbol is what? P. So phosphorus is a very reactive non-metal element. So if phosphorus is kept open in air, it is a solid non-metal. Understanding? So it reacts with oxygen of air and will catch as fire. So if we'll expose the potassium outside the atmosphere, then it will automatically will catch the fire. Understanding? So in order to protect this phosphorus from atmospheric air, it is stored in a bottle containing water. So it will be stored in water. Understand? Like that metal sodium and potassium we used to store in under corrosion. Like that if it comes to the phosphorus, we have to store in under water, because they will now they will react with water and we have to store them in corrosion. But here they will not react with water. That is why we are storing in water. If you expose to atmosphere, it is dangerous. There also if you expose to atmosphere, it is very dangerous. That is why phosphorus containing minings, phosphorus minings and all, if you'll see that their houses and all, if suppose in our home, if you will contain any kind of phosphorus containing substances, automatically without any kind of fire, they will catch fire. Understanding? Because that is the nature of phosphorus. So this is about the non-metals reaction of water. Metals and non-metals reacting with water. So non-metals does not react with water. So they will show no reaction. Understanding? So like that, if it comes to the next one, that is reaction with acids. So that is the third one. So if it comes to the reaction with acids. Reaction with acids. So now, if you'll observe here, the same thing, like if you'll observe, most of the metals react with dilute acids. Here I am taking only diluted acids. In class 7th, I have only taught you that concentrated acids and diluted acids. You remember, concentrated acids is very dangerous. So they are they will cause severe burning actions, and they will even it's like we can kill the human also. It is very hard to handle, very dangerous to handle. So always we'll react to any kind of, we'll observe the reactions in our laboratory and all with the diluted acids. Means acid percentage is less and water percentage is more. It's like a solution. Understand? So if we'll come to the metals, so if we'll observe, metals will react with acids and they will form salt. Salt means in the sense of not eating salt, some kind of a chemical salt, and along with that they will produce hydrogen gas. So any kind of metal will react with acid. If we'll take any kind of acids, where we are having different kind of acids, understanding acids, so they used to produce some kind of a chemical salt, along with that they will produce hydrogen gas. Understanding? So only the less reactive metals like copper, silver, gold do not react with the diluted acids. So if we consider copper, copper symbol is Cu. Understanding? And silver Ag. Like that, gold Au. Understanding? Like these metals, they do not react with the diluted acids. DIL is a shortcut for diluted acids. But these also can react with the concentrated acids. Understanding? So basically these three, like this less reactive metals, they are not reacting, they will never react, they will never show any kind of reaction with diluted acids, but basically this also will show with the concentrated acids. Understanding? So the vigorous reaction of, vigorous means very dangerous. The vigorous reaction of metal with dilute acid depends on the chemical reactivity of the metal. So depending on their reactivity, some of the metals react very explosively, violently means very explosively with the dilute acids. So, and some metals react rapidly with the dilute acids, and some metals react with dilute acids only on heating. Understanding? And some metals do not react with the dilute acids at all. Understand? Example, copper, silver, and gold. So the reaction of, suppose if we'll take example, suppose if we'll take the reaction of magnesium. Let me take magnesium. So if we'll consider the magnesium metal, understand, if we'll start reacting with acid, so let me take that acid as a hydrochloric acid. Hydrochloric acid, then we used to get magnesium chloride salt. Understanding? So magnesium chloride salt, and as well as we used to get hydrogen gas. Understanding? So here, if you'll observe, magnesium symbol is what? Mg, and hydrochloric acid means HCl. So if you'll observe this reaction, we used to get magnesium chloride means MgCl2 plus also we used to get hydrogen. So this is the chemical reaction, hydrogen gas. So here, see, magnesium is reacting with a diluted hydrochloric acid and it is forming MgCl2, magnesium chloride. So it is a chemical salt. You have to remember, this is the salt. Understanding? So this is the thing. So like that, if we'll take aluminum, iron, zinc metal also react with dilute hydrochloric acid to form the corresponding metal chlorides and hydrogen gas. So always, if this salt contains some metal along with that chloride. Understanding? So that is only used to called as chlorides. Understand? Metal chlorides and hydrogen class. If you suppose aluminum will react with acid, it will form aluminum chloride. Like that, zinc will react with acid, zinc chloride. Iron will react with some kind of acid, iron chloride. Like that, they will form always metal chlorides, and along with that, they will release the hydrogen gas. So this hydrogen gas burns with a pop sound like a tap 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 tap. Understanding? Pop sound when a lighted matchstick is brought near the mouth of test tube. So these experiments we all will study in higher classes. You don't need to work. Understanding? So this hydrogen gas will release. So you have to confirm that is it a hydrogen gas or some other gas. So here, if you'll observe this hydrogen gas, how we can conclude? If we'll try to keep this some burning lighted matchstick, if you'll brought near this where this gas is producing, then you can see that it will burn with that hydrogen gas will burn with pop sound. So we can say that it is hydrogen gas. Understanding? So the less reactive metals like copper, silver, gold do not react with the diluted acids like diluted hydrochloric acid or dilute sulfuric acid, but the copper, silver, and gold, understanding, they will react with the concentrated acids. And you have to remember that with the diluted acids, these kind of less reactive metals, they cannot produce hydrogen gas. Understanding at all? Okay. So like that, if it comes to the copper metal also, so copper metal also do not react with dilute sulfuric acid to produce hydrogen gas, but copper metal, however, it will react with hot and concentrated sulfuric acid. Remember, copper metal cannot react with diluted sulfuric acid. Understand? Sulfuric acid formula is H2SO4. You remember, these are the common acids which we are using in most of the chemical reactions, either hydrochloric acid or sulfuric acid. Sulfurous acid is H2SO3 that we have seen in last class. This is sulfurous, ROUS, sulfurous. This is sulfuric acid, ric acid. Understand? That is the difference. Okay. So if we take a copper metal, however, react with hot and concentrated sulfuric acid, but no hydrogen gas is produced. That is the most of the thing you have to remember. So if we take the concentrated sulfuric acid, hot and concentrated sulfuric acid, so basically metals will produce hydrogen gas along with that metal chloride salt. Understanding? But copper metal, even though if it will, it basically does not react with the diluted hydrochloric sulfuric acid, but it will react with the concentrated sulfuric acid, but it will never produce hydrogen gas. So understand. So these reactions, if you want these reactions, we'll study in higher classes in 10th plus 1 plus 2, that you don't need to worry. So like that, the reaction of metals with acids have some important implications in our daily life. Suppose if we'll consider certain foodstuffs like citrus fruit juices, we can say like a lemon, orange, like lemon juice, orange juice, like a pickles, chutney, and curd, etc. They contains acids. Understanding. So when foodstuffs containing acids are kept in iron, aluminum, and copper containers, so the acid present in them react with this metal of the container slowly to form toxic salt, means very poisonous salts. Understanding. So that is why always pickles we will never store in aluminum foils or any kind of metal containers. Always we will store in containers which will made with some kind of a jars which will made with a special clay, because clay cannot react with this kind of metals because they contains acids. That is why we should not store this kind of substances in any kind of metal containers, because this metal will react with that acid which contains that the what we can say, that the substance which the some type of acid this contains. So the both will react and they will form some other kind of this metal salt, metal chloride salt, that is only called as, it is very dangerous one, toxic salt or else poisonous salt. So and these toxic salts can make us sick or else damage our health. So iron, aluminum, copper containers, understanding, iron containers, aluminum and copper containers should not be used in understanding, should not be used to store acidic foods like citrus fruit juices, understanding, orange juices, lemon juices, or else some kind of pickles, chutney, and including even curd also. Curd is okay, every day per day we will finish it within 1 or 2 days, okay, but these all are not good. For example, if we'll take, we cannot store lemon pickle in an aluminum vessel because the acid present in the lemon will react with aluminum metal of vessel to form toxic salts which can make us sick and damage our health. That is the thing. Okay, like that. This is about the reaction of metals with acids. So which acids are diluted acids. Like that, if it comes to non-metals. So non-metals, again, if you'll observe carefully, so non-metals like water, non-metals cannot react with water. Like that, non-metals cannot react with dilute acids. So you have to remember that. So non-metals understanding, do not react with acids, do not react with diluted acids, understanding, but concentrated acids it will react, that we will study in higher classes. Do not react, for the your level it is enough. Do not react with acids. Which acids? Diluted acids, diluted acids, understanding. So non-metals do not react with diluted acids to form salt and hydrogen gas. For example, if you take any kind of non-metal, suppose like a solid non-metal, sulfur powder, or else if you take carbon is in the form of charcoal powder in a test tube, and if you add some kind of hydrochloric acid or else some kind of diluted hydrochloric acid or sulfuric acid, then no reaction takes place even on heating also, understanding. So this shows that sulfur and carbon non-metals do not react with diluted acids and hence no hydrogen gas is produced, understanding. But some of the non-metals, however, they will react with hot and concentrated sulfuric acid. You remember that is why I said basically they won't react with they will never show any reaction with the diluted acids. But few non-metals, they will react with a concentrated hot and concentrated sulfuric acid and nitric acid, but no hydrogen gas is produced in that such cases. Okay, this is about understanding. So we all will study these reactions, all will study in higher classes. You don't need to bother. You have to remember that few non-metals will react with a concentrated hot and concentrated sulfuric acid and nitric acid, but they won't liberate means production of hydrogen gas. That is, you have to remember, they won't produce hydrogen gas, understanding. So like they will but they will react with concentrated sulfuric acid as well as nitric acid. You have to note it down, nitric acid. So this all these two must be even including they need to be hot. So this is about reaction with acids. So like that, if it comes to the next one, reaction with bases. So if you are reacting with acids means next you have to study reaction with bases. So now again bases also two things. So bases, metals can react with bases, and like that as well as non-metals also can react with bases. So how it will be, the reaction will take place or not, we have to see. So if you take the bases, understanding, so bases now, okay. So now if it comes to metals, some metals, remember not all the metals, till now all the metals, now some metals react with bases to form salt and hydrogen gas, like acid, the same thing. Some metals, not all the metals, some metals only will react with as a bases, and they will form salt, understanding, plus they will release hydrogen gas. It's a common. Okay, so now suppose the common reaction, how we can write for this metal. So if we take the metal, so metal plus base which used to produce, understanding, salt plus hydrogen gas. Salt plus hydrogen gas. Suppose if we'll take aluminium, understanding. So if aluminium symbol is what? Al. So Al, aluminium is reacting with, understanding, sodium hydroxide. So before I have already taught you that sodium hydroxide. What is the formula of sodium hydroxide? NaOH. If you want down, you just know to write it down. I am writing you directly the chemical equation. If you want, you can write word equations. So sodium hydroxide will react with aluminium, understanding. So aluminium and sodium hydroxide, we used to get a salt called as sodium aluminate. I will write it. Na, sodium aluminate, AlO3. That is the formula of, AlO2 is the sodium aluminate. Along with that, we used to get hydrogen gas. If you want, write this name also. Sodium aluminate. Sodium aluminate. Understand? So this is about metals. Some metals react with the bases to form respective salts and their hydrogen gas. Like that, if we take zinc metal also react with the sodium hydroxide solution to form hydrogen gas. Zinc also will produce hydrogen gas when reacting with the sodium hydroxide. Like that, if we take aluminum and zinc are the two common metals which react with the bases like sodium hydroxide. That base also I am saying you, aluminum plus zinc. These are the common two metals which will react with the base and they will produce hydrogen gas. Understanding? But in generally, we can say that some metals react with the sodium hydroxide to produce hydrogen gas. Note that all the metals do not react with the bases to produce hydrogen gas. Understanding? Means like a sodium hydroxide base. This is the higher concentrated base. You have to remember. Bases also will be concentrated and diluted. So if it comes to the next one, second one is what? Non-metals reacting with bases. So non-metals reaction with base. So if you'll observe, non-metals react with bases like sodium hydroxide, but no hydrogen gas is produced. They will react with the bases, but no hydrogen. They won't liberate hydrogen gas. That is, you have to remember. Understanding? So the reactions of non-metals with bases are very complex reactions. Means we used to get more than 2-3 products, very tough reactions. So these all reactions for your classes, it is not required. So we will study these reactions in higher classes. You don't need to worry. So this is about the reactions of metals and non-metals with the bases. So with this, I'm going to end this today's class. In next class, we are going to study the most important thing that is called as reactivity series of metals. So what is the meaning of this reactivity means? In this class, if you will observe, I have told you that so many times, few metals are very reactive and few metals are reacting slowly, and few metals are cannot react with even with a hot steam also. So this is so the arrangement of these metals according to the what we can say that according to the reactivity speed is called as reactivity series, that we will study in next class in detail. Okay, so now I'm going to end this today's class. Thank you. Have a nice day. Thank you. Bye.